Okay, good afternoon, everybody. This is question 53 from chapter 12. This is the first of a couple regarding concentration calculations. Okay, so we are looking at a sodium chloride solution. We're given a little bit of information. We're making the solution with 112 grams of NaCl. So that's equal to our mass, NaCl. Let's see, we've got a total volume. The total volume of the solution is 1 liter, okay, which is helpful for some. We also have a density of the solution. Well, it's not really that. So we got a density of the entire solution. Good grief. Of the whole solution at 1.08 gram per milliliter. Okay, so we're looking for molarity, molality, and mass percent. All right, so we want molarity, we want molality, we want mass percent. Okay, so let's do the molarity first. Molarity we write as the moles of the solute over the liters, or the volume of the solution. All right, so that should be moles of sodium chloride divided by the total volume. Right, so we can get our moles by dividing the mass that we have by the formula weight of sodium chloride. So we're going to divide 112 grams by the molar mass, which is 58.44 grams per mole. So we'll cancel out the grams, and we're dividing this over a total volume of 1 liter even. Right, which is a fantastic simplification. That is going to give us a total molarity of 1.916. 916. And that's in units of moles per liter. Right, and we've got three numbers in both of these, 3 significant fingers, so we'd be confident in the 1, so this would be 1.92. Okay, next let's do molality. Molality we define as moles of the solute, right? So NaCl in this case over the mass of the solvent, which in this case is water. So we have the number of moles of our solute of sodium chloride, right? We calculated it in this expression here, right? We've got 1.916 moles. So I guess we can write that somewhere up here. Moles of sodium chloride, we have 1.916. Okay, so what we need to find the mass of the solute. So what we can do is, we know that we have 1 liter total of this. We can multiply it by the density here, and we can get the amount of grams we have. So let's do that. First. We'll get rid of this expression for now, and we'll come back to it once we have our mass of solvent. So mass of H2O, all right, is going to be equal to the mass of the solution minus the mass of the solvent, or solute, excuse me. So we can get the total mass of the solution by multiplying the density by the volume. So this is going to be volume times density of the solution, and we're going to subtract from that the 112 grams that we know that we start with. 112 grams. Okay, so we've got to be a little careful with the units here, because we've got a liter multiplying by something with milliliters. So we're just going to multiply this by 1,000, because we've got 1,000 milliliters in 1 liter. So that is going to give us 1,000 milliliters times 1.08, right, grams per milliliter. So we're going to cancel both these out, and we'll have an answer in grams. Still subtracting the same number. And this is going to give us 1,080 grams. 1,080 grams minus the 112 is going to give us 968 grams. Right? And usually molality is reported in kilograms of the solvent. So we're going to turn this back into kilograms, which means we redivide by 1,000. So we'll have 0.968 kilograms. Okay, so our molality then of this solution is going to be equal to, I just realized sometimes this is written with a B here. It's sometimes written with a B, in which case you'd be writing these with small m's. So hopefully this isn't confusing anybody, but just in case, let's change this to a B. I'm trying to remember what I saw Dr. Shepard using. Right, let's try this. I remember he liked the Atkins textbook, and that does use B in it for molality. Seems to be an English thing. Okay, so we're dividing moles of sodium chloride by the mass of the water, which is going to give us 1.916 moles, even though we're confident in 3 numbers there, divided by 0.968 kilograms. Whoops, looks like I deleted something there. Okay, and we got a total molality of 1.979, and this is going to be in units of moles per kilogram. And we'd again be confident in our 3rd digit there. Okay, those are those done. Definitely see molality a lot more in the upper years there. They describe molarity as a treacherous variable because the volume varies with the temperature, so that does go. Okay, for mass percentage, mass percentage is just defined as whatever your species of interest is. So let's say the mass of J, and that's going to be divided by the sum of all the masses I in the solution. All right, and in this case, J is going to belong to I, meaning that we include J in this calculation. So in this case, it's our total mass, which was 1,080 grams. That's what we had before we subtracted the 112 away to get the 968 grams here. So we divide 112, 12 grams of sodium chloride. We divide that by 1,080 grams total in the solution. I guess we multiply by 100 because we're looking for a percentage. All right, and we calculate 10.37%, and we'd be confident in the 3 here, so this would be 10.4%. Okay, there's the basic crash course for the concentrations. We will see you for solutions formation.